I'm ready.
Muito bom dia para todos. Então, nós vamos fazer o nosso seminário dessa semana com um palestrante convidado, Patrice Mates, vem lá da Universidade de Rapperswil, na Suíça. Ele está passando uma temporada conosco aqui e o projeto dele envolve a avaliação de desempenho do nosso ônibus elétrico. Então, o Patrice já está há algumas semanas conosco, vai ficar mais um mês, e ele vai apresentar então uma palestra em inglês sobre os dados que ele tem trabalhado do nosso ônibus. Então, Patrice, the floor is yours.
Thank you. So I would like to welcome you to my first presentation. I've been here for the last 6 weeks, as Ricardo already told. It wasn't always easy to read all these Portuguese instruction manuals, whatever, but I have found some guideline, and Aline was also really helpful to translate or help me out if I needed something. And I finally got to some results, so let's start. Before I start, I want to tell you that whenever you have a question, if you see something that is not clear, raise your hand and ask the question. So, first I will tell you a little bit about myself, what my personal motivation was to come here, what my little career was until now. I will tell you some key data about the Sapiens Spark, about the Electrobus, and I will go ahead and tell you how I actually got all the data I filtered and gathered and made an interpretation out of it. And at the end I will make some future perspective, because my bachelor research is not done yet. I will still have a whole month, and I will use this time to use some more research on the electric bus. So yeah, I'm Patrice Mates, I'm 25 years old. I'm currently living in Switzerland, and my start in the electric world was in 2008. I did my apprenticeship. It's kind of a training you receive, a theoretical and practical training for over 4 years. So I was working at the multimedia store, which was selling high-end products such as TVs, satellite installations, multimedia room systems, and through that year I learned a lot about electronics. Later on I traveled through South, Middle and North America, when I also passed through Florianopolis, and this is also one of the reasons I wanted to come back here, because it's really beautiful. In 2003 I made my qualification year, which allowed me to enter the university in Rapperswil, where I'm studying right now renewable energy and environmental engineering. I will be graduating in December and finally start to work. When I heard about this project from my teacher, Professor Hebele, I was really interested, because electromobility is a big trend right now in Europe and all over the world. So I was pretty happy to receive the opportunity to come here and make my research about it. So this is the laboratory as we know it today. There are several technologies integrated in the buildings, PV technologies, with different power ratings, and it makes it really great to make research on and also compare the different technologies with each other. We have a total of 105 kilowatt power, and as far as I know, block B is not working correctly, so we have a power production of around 90 kilowatt. Let's move on to the Electrobus. It holds up to 38 passengers, and on an average trip, if I take all the trips and I calculate the average, we have 5.3 passengers. The maximum velocity is 80 kilometers per hour, and its autonomy when discharged, when we take the whole battery and we discharge it from 90% down to 20%, we get a range of around 70 kilometers. The battery packs are all mounted on the roof of the bus. There are exactly 8 battery packs, but 2 battery packs are connected in series and 4 in parallel, so we get a capacity from around 130 kilowatt hours. And a voltage, depending on the charge of the battery, between 600 and 700 volt DC. And the electric motor is in the back of the bus, and it generates up to 370 kilowatts, which is apparently 500 horsepower. Normally the bus travels between 100 and 200 kilowatts, which is around 200 horsepower. The weight of the bus is 16 tons, so it's quite a big one and really heavy, also because of the battery packs, which are really heavy and mounted on the roof. A special feature of the bus is the regenerative brakes. So whenever the bus actually brakes, there can be energy restored back to the battery packs, which make the average autonomy much bigger. So the travel of the bus can be over a longer period. And this is how it actually works. So we have the braking pedal, and whenever the braking pedal is pushed to the first stage, it's actually only the engine that is braking and restoring the energy back to the battery. When there is an emergency or a fast stop, he can push the brake all the way through and also activate the brakes of the bus itself, the hydraulics brakes. Everything clear until now? Great. This is the route, how we know it. It's from Sapiens Park down to Jufski. Takes around 30 minutes and is a range of 25 kilometers. This route gets traveled 5 times a day, and every time the bus returns back to Sapiens Park on top of the map, we recharge the bus. So let's move ahead to the goals of my bachelor thesis. The main core research will be the performance of the electric bus. I want to know what factors are actually influencing the discharge of the battery and to make a chart out of it. So we knew in the future which factors are actually important and to look at to extend the range of the bus. I will also be analyzing the power production of Sapiens Park, so we know the area we need to cover the need of the electric bus. We'll see later on that the electric bus is quite a big energy user, and if we want to have recyclable energy used for the bus, we need to regenerate it through PV, for example. At the end, there will be a conclusion for the dimensioning, as I already said, how much area of PV photovoltaics panels I need to provide enough energy for the bus. This second analysis I will be doing this month, so right now I will only present the performance of the electric bus. Let's make a little timeline to show you guys where I actually got the data from. So we have the bus that starts at Sapiens Park with 92% of battery capacity. It travels the 25 kilometers to Jufski, and it gets down to 76%. When driving back to Sapiens Park, it reaches its final discharge of around 40% of its whole battery capacity. So the bus driver gets out and plugs the charger inside the bus and charges the bus with a power. Let's say the power has output power of 75 kilowatts for 1 hour. So the battery gets charged again from 40% to 90%. But as already we saw in the beginning, the bus had actually 92%. So first we estimate the charge of the bus, which is the difference from 40 to 90%, which is 64 kilowatt hours. The battery holds up 128. And if we want to know the consumption over that trip, going to Jufsky and coming back, we take the difference of 52%, because the bus started with 92% of battery capacity. And we get a final consumption of 66.6 kilowatt hours. Now, the charger itself holds up an electricity meter. It's kind of the same device you have at home that counts your electricity and counts how much energy you have to pay at the end of the month. And here we get a measured charge, so the charger actually counts every electron that is leaving the charger and says, okay, at the end of the charge you reached 60 kilowatt hours. But now we only charge from 40 to 90%, so there is 2% missing in that calculation, which I have to calculate with the SOC on the right hand side. So 2% of 128 kilowatt hours added to the measured charge is 62.6 kilowatt hours. So we have kind of two values for the same thing. Everything clear? Good. So to understand what the actual difference is between these two, I tried to compare two technologies used. So the states of charge actually access the battery, and it asks the battery or the battery management system, what is your voltage, what is your temperature, how much charge do you actually have? Then the battery answers, okay, I have 90%. And this is the SOC 0. And from that point on, the battery gets discharged, and every electron that is actually leaving the battery gets subtrated from that value. And the actual charge is actually monitoring the whole charging process when charging the bus. The formula above is a formula that gets used quite often for lithium batteries, because right now I didn't fully find out what the actual BMS of the electric bus is doing to calculate the SOC. So right now I'm just using this formula to compare these two. So the accuracy of the actual charge monitored through the charger is much more precise, but it cannot make a difference between the uses or the consumption of the electric bus when getting charged. Let's say you park your electric bus and you charge it, and you have your air conditioning turned on. So while you're actually charging your bus, the energy is used also by the air conditioning, which can mislead the information of the consumption during a whole trip. So there, the SOC is much more accurate. But whenever I turn off and turn on the bus again, the question will be asked again, what is your current, what is your voltage, what is your charge? And there is where the information gets kind of different and wrong. But if we want to monitor the discharge of the battery over a whole trip, and which I will be showing you in a minute, it's better to use the SOC, because the actual charge I cannot monitor right now. So this is a chart from the electric bus. It's quite big. So we can see here on the left-hand side the battery packs, which are providing energy for different inverters and different components of the electric bus. On top we have the biggest user, the engine of the electric bus, And on the lower side, we have different components such as hydraulic pump, water pump, air conditioning, light, etc. So on top, we have the data logger, which provides us with different data such as the current or discharge of the battery. We have the power of the motor, of the inverter, the output power that actually gets delivered to the engine, and we have also the power that is created through the generator. So whenever we are braking, we're actually giving back energy to the battery pack. And whenever I use energy through the engine, when I'm accelerating, I use energy from the battery pack. We also have access to other values such as voltage, current, temperature, and also the GPS data, which I will be using for speed analysis. So I can see what is the speed or what is the average speed of a travel or a trip. This one is a monitored data from 2 different days. They both start at 0 from Jufsky and travel 25 kilometers to Sapiens Park. On the left-hand side, we can see the discharge of the battery. So while or during the trip, we use a capacity of 23%. Now, why is there a difference? Why we have, for the same trip, for the same amount of people and with no usage of air conditioning on both of their trips, a different discharge? That is what I'm actually doing the research on. In this case, my best guess is the average speed. If we compare the 2 trips, we see that one was much faster than the other one, meaning that the engine was driving faster and at a higher RPM, which makes it less efficient. We also have, we can see that the SOC is getting lower again, which means the battery is getting charged. And this is actually through a mountain at the beginning of the trip. So we travel all the way up to the mountain, we use a lot more energy because it's really going uphill. And when the bus is going downhill again and braking with his regenerative brakes, we restore some of its used energy back to the battery pack. And this is why I think the engine is the main, or the travel speed is the main factor of the higher discharge of the battery. If we look at the consumption of all the components of the bus, we see that the engine is taking 75% of the whole energy. And only 25% is used for hydraulic pump, light, etc. And there are also some efficiencies involved. As far as I calculated, I can say that the battery, when discharging, has an efficiency of 87%. And if we take a travel time of 1 hour, this energy gets used. So we have analyzed the whole trip going from Sapiens Park to Jufsky and going back to Sapiens Park, where we use 51.5 kilowatt hours for the engine, and 13.5 kilowatt hours get restored through the regenerative brakes. So we have a total consumption of the bus of 38 kilowatt hours. But why? Because the efficiency of the battery is lower, we actually get a discharge of 42 kilowatt hours, or a consumption of 42 kilowatt hours, which is exactly 75% of the whole consumption of the bus. When using the air conditioning on, it's around 66% of the battery used through the engine. So let's see at the first chart. I analyzed various trips with different average velocity. And average velocity means that I only calculate when the bus is moving. So whenever the bus stops, all the zeros I took out of the calculation, and I only have an average velocity here when the bus is actually driving. On the left-hand side, we see the energy use through the engine, and we see a trend going up. So the faster the bus is actually traveling, the more energy is being used. And I made a second chart with comparing the amount of passengers inside the bus. So whenever there is a high load of passengers, you actually think that there is probably a higher discharge. If I have a full bus of 38 people, it must discharge more than if there is only one person sitting inside. But the data, and as far as I see here on the chart, is pretty much even, which means it doesn't really matter. And that is probably why, because the bus itself has a weight of total of like 16 tons. And if I take 38 people inside the bus, which is around 2.5 tons, it's only around 15% of difference, which is not too much. This chart I wanted to draw to show you guys the availability of the bus. So whenever there occur a problem or a trip was not going to happen, I was making a chart out of it. So we see that in August there was not such a good month, and there were some trips not happening. And mainly it was because of maintenance. So whenever the bus had to go to maintenance, if there was a control or a reparation from back, it had to go to maintenance, and then some trips were not going to happen. And another bigger part of this unavailability was the infrastructure on the bus. So whenever there was a blackout and the bus couldn't get charged, there was also a trip not happening. But overall, we see that there is an availability of 89%, which is really high. Whenever I made a research on internet and you reach around the 90%, you can really almost hold up with the normal diesel buses. And here are some key data to take away. We have a total mileage of 37,486 kilometers, which were traveled with that bus. Today I think it's around 39,700 kilometers. So we will reach next Monday the 40,000 kilometers, and that means that the bus traveled one time around the globe. The total consumption since 6th of March till the 31st of October is 40,000 kilowatt hours. So we see the bus needs quite a lot of energy, and if I take the cost of 1 kilowatt hour, which you take from the net, it's around 200 reais a day, which you spend on electricity. And if we take that consumption of the bus of 1 month, which is around 5,200 kilowatt hours, we use energy that is actually being used of for a person household during a whole year. So we see the electricity of the bus is quite high. That's my final chart. Here you see the display of the electric bus, which I'm currently monitoring with a GoPro, because I cannot access the data, so I need to make a video and analyze the data later. I want to say thank you to Ricardo for having me here, for letting me make my research about electromobility, and also to my professor in Switzerland, which made me give the opportunity to come here. Thank you very much.
Thank you, Patrice, for a very insightful presentation. You really covered all the aspects that the bus, on the bus over this 6-8 months period that it has been running regularly since we started regular operation. Tem alguma pergunta da plateia para o Patrice? Sem perguntas, todo mundo feliz. Okay, so it means that your presentation really covered everything that people might want to know. So we thank you very much, and we're glad to have you here, and we hope you're enjoying your time with us. Thank you.
Thank you very much.